Hello and welcome in Teach Max videos. Let us design an industrial building now. Okay, so already we design a truss, design a gantry girder also. Okay, in the industrial building. Now here I'm going to focus on all the elements, all the structural elements of the which are comes in the industrial building. So that all we are going to design here one by one. Okay, so it's like a project only. So definitely in all universities for design of steel structure subject, this part is an term work part for all. Okay, so one project is there, that is design of an industrial building. Okay, right from plan elevation, right from the plan, yes, we are going to design it thoroughly up to end. Okay, so let us see what is the given data generally is available for the designer, and on that basis how the designer design this whole building. Okay, whole industrial building or industrial shed we can say. Okay, so design an industrial building including truss, purlin, gantry girder, column and column base. Okay, so almost the 5 structural elements that we are going to design: purlin, truss, gantry girder, column base. Okay, so with the following data. So what is the data available? Of course plan area is available. Okay, where exactly the industrial shed is rest or where we are going to construct. Okay, so plan area is available 30 meter by 16 meter. Height up to column level is assumed because it depends on the requirement of industry. The height of the column, the proper height of the industrial building is decided. Then type of truss is the choice of designer actually. So Wagh truss is considered. Okay, so Pratt or Wagh or Fink truss generally is provided for the shorter span. Okay, so shorter span of the industrial building is actually the span of the truss. Okay, so Wagh truss is provided. Pitch is also assumed. It is, we know, depends on the type of roofing material. GI sheets here it is used. Okay, so based on that only we decide the pitch. So generally pitch is 1/4 to 1/6 of the 1/4 to 1. What is pitch? Pitch is the height of the building to the ratio of height of building to the span of building. Okay, so span of truss, height of truss to span of truss. Okay, so that is pitch. Okay, so this is the given data. Also here opening is assumed that normal permeability we are going to provide. It means 20%, sorry 5% opening we are going to give in the walls. Okay, location is Pune. Here location is also important for the wind load calculation, so location is also mentioned. Life of structure is assumed 50 years. Okay, so based on that only we design it. Safe bearing capacity of soil for the hard strata, first of all we get this first we need this value, and that is definitely we get it by taking test on hard strata, and the SBC of soil is 250 kilonewton per meter cube is given. Slope and terrain category is also you can assume depends on the site condition. Fine. Okay, so this is the given data for the truss and purlin required. For the gantry girders, of course, which type of crane you are going to provide in the industrial building? EOT crane, electronically operated. What is the crane capacity? What is the weight of trolley including crab, including hook and all assembly? So that weight is also given. Minimum hook approach is also required, so that also given 1.2 meter. Self weight of crane girder is assumed. Okay, so either it is given in kilonewton or it may be given in UDL, total UDL, or it may be given in UDL intensity. So easily you can find out this. Then wheel spacing is also very important. It should be given or it can be assumed, depends on the availability of the crane. Okay, so self weight of gantry also you need to assume. Okay, also self weight of rail you can assume 0.3 kilonewton per meter. Okay, so all these are the given data particularly required for design of truss and purlin and gantry girder. Okay, so let us design one by one. Okay, so first of all we are going to focus on the